Okay, so for today's class, we have the new 9709 momentum, and this is a relatively new topic. So, if I can recall, I did not have this topic in my time, and back in I think 2018 or 2018 years. So this topic came in afterwards. So, but this is a very basic. We have done this in detail in O levels a little bit, in O level, but in detail in AS physics. If anyone of you has over here AS physics, so he must have seen this topic before. And the concept is also almost 95% everything is the same as the AS physics. Momentum. So momentum is what? The basic definition of momentum is it is the product of mass and velocity of an object, and this momentum is a vector quantity. So this means that the sign, the direction is very important over here for momentum. Okay, positive momentum, negative momentum, and the direction, left moving, right or left or up or down. The momentum directions will be important. We will see in questions as well. So momentum symbol mostly they use is as P. So P is equals to M times V, and the units would be simply kg times meter per second. So kg meter per second. This is the most basic formula for momentum of an object. For example, there's a car. A car is of mass. Car mass is, let's suppose, 1000 kg and has velocity of 30 meter per second. So find the momentum of the car. So momentum of the car would be simply 1000 times 30. So 30,000 kg meter per second. Okay, this is simple. Finding the basic momentum of any object. If it is in motion, then you would have the momentum. Sorry. If something is stationary, so velocity would be zero. So if velocity is zero, then momentum would be zero for any stationary object. A stationary object means it is not moving, it is at rest. Stationary at rest object, momentum will be definitely zero because velocity is zero. If an object is accelerating, definitely it would have an increasing momentum, right? Because of the velocity is increasing, accelerating, velocity increasing, that's why the momentum would also be increasing. If it is decelerating, then the momentum of that object would be also decreasing because velocity is decreasing. So it's a simple product of the mass of an object and the velocity with which it is in motion. That's it. Then the important part is we move on to find the impulse, impulse or the change in momentum. So the next thing is impulse or change in momentum. It is what, just like you can see over here, change in momentum. So mass times final velocity minus mass times initial velocity, or if you can take this mass as common, so you will get v minus u, or and you can also write it mass times change in velocity, because change in velocity we know it is what, v minus u, the final velocity minus the initial velocity. So this is one of the things that they may ask you to find. For example, let's suppose there is a ball and this is the wall. Okay, wall. Direction is very very important. Okay, don't forget about the direction. Let's suppose this is a what do we say, a ball, simple ball, and this is a mass of 100 grams. So let's suppose it is going towards the wall. It is hitting with the point, the second at with the moment at which it is hitting the wall, it is, let's suppose, positive 2 meter per second. And when it is hitting and coming back, when it is rebounding, the final velocity with which it is coming back after the energy losses, everything. Let's suppose it is 1.5 meter per second. So they would ask you to find the impulse of the ball. Okay, what is the change of momentum of the ball? So direction is very important. So again, you would use the convention, direction convention. Okay, so positive to the right side, let's suppose. So if you want to find the change in momentum, it would be mass is a constant part. We know mass won't change for any object. The only thing which can change is the velocity, which would be causing the change in momentum. Mass is a constant. Mass is for any object, it doesn't change. So final velocity, it is in the opposite direction. Look, so minus 1.5, and then minus initial velocity is to the right side. So you have minus 2. So when you solve this, you will get what? Minus 3.5. And mass is 100 grams. So this would be 0.1 kg. So this becomes negative 0.35 kg meter per second. This is the change in momentum. And the negative sign over here shows us that the direction of the impulse is to the left side. Okay, so they would ask you to find impulse as well. It's a very basic question. And impulse is simply the change in momentum of any object after collision. Okay, so you will see that whenever there is a change in change in momentum, it would be after a collision. Sometimes there would be two cars colliding, there would be a car and a truck colliding, there would be a ball colliding with the ball, with the ball. There would be two snooker balls, 8 ball pool, they also collide together. So that is also a collision. So these are very common examples they use in the past paper questions as well. When two things would be colliding, then you would have the impulse on either of the objects, because velocity would change, the direction of the velocity would change after the collision. Okay. Now, moving further, this is simple. Again, you're just using this change in velocity and multiply by time, you will get the impulse. Now, using this impulse, we can find the force also acting on the object. Force, we know it is, now you will learn a new formula. Force is change in momentum upon time as well. So how much time it took for the collision? So you can write it like this as well. M, change in velocity upon time, and change in velocity is what? Acceleration, isn't it? So this means, look, F is equals to ma. This is the same thing. So the actual formula for force is coming in from here, the change in momentum upon time. So let's suppose they tell you that the collision, let's suppose this collision, the ball went towards the wall and came back. The duration of the collision was, let's suppose, 0.1 second, 0.2 seconds. So they can ask you to find the force exerted on the ball by the wall. So you would divide this momentum by the time, which was 0. Let's suppose 0.2 or 0.2. So change in momentum divided by time would give you the force acting on the object. Okay, this thing is not as frequently asked, okay, but this is a concept we should be aware of. Okay, you might have seen this in your AS physics as well. AS level physics. Change in momentum upon time is the force, can give you the force exerted on the wall or on that object. Okay, all good till here? Any questions?
No, sir.
Okay, the next thing that comes in, these are again very simple basic things. We'll move on to the next thing up until we get to the type of questions that come in the exam. The next thing is conservation of momentum. So this tells us conservation of momentum, just like conservation of energy, for any closed system, momentum is conserved. This means the initial total momentum would be equal to the final total momentum is conserved. By a system means that there would be, let's suppose, we would have a system of two objects. In our case, we would have two objects, a system of two objects. For example, let's suppose there is a ball A. Again, there's a smaller ball B. They both are going towards each other with their particular velocities. Let's suppose this is VA, this is VB. So definitely they would collide. And when they collide, the situation would be something like this. This is the ball B, this is ball A. So we don't know the directions, we will consider them, we will find them out. They can either go both in the same direction as well. They can either both go in opposite directions again. We don't know about that, but right now I'm just trying to explain it to you. Okay, this is the collision, after collision and before collision. We have two situations. You will see in the question as well when you see the past papers. You would have situations like these: before collision and after collision. So what do? You would equate the sum of momentum initially with before collision. It would equal to the sum of momentum finally after collision. So before collision, we have to consider the signs as well. Okay, the sign of the direction, okay, of the velocities. So right now, to the positive side is always the right side. Okay, so if we find the initial total momentum for mass A and mass B combined, so this would be mass A times velocity of A plus mass B times minus velocity of B, because it is in the opposite direction. Okay, it's on the left side, and this would be equal to the final total momentum, which would be mass of A times minus velocity of A plus mass of B times velocity of B, which is again right now in the same direction, positive direction. Okay, so we have to input the signs according to the direction. Direction is very important. If you'll mess up the direction, then definitely you will get the wrong answers. So they give you condition like these, they give you the situation like this, and then you form their conservation momentum equation like this, and then find the unknown things. Right now I have given you a very generalized situation over here. We don't know the actual values. Okay, so generalized values over here. So this is how you would form the equation, the momentum equation, conservation of momentum. You would have two objects in a system, they would be colliding one way or the other, and then they would give you the initial velocities, and then they would ask you what is the final velocity and something like that and everything. Okay,
Yes, sir.
let's use now values, some values. Let's suppose your mass A is 2 kg, your mass B is 0.5 kg, and velocity of A is 3 meter per second. This is the speed. Okay, velocity of B initially is let's suppose 5 meter per second, and velocity of A after after collision, it is equals to, let's suppose, 2 meter per second. They would ask you to find the velocity of B after collision. So again, here also we would have to assume the direction initially. And if we get a positive answer, we would say that yes, the assumption was good. If we get a negative answer, this means that the assumption was the opposite. Okay, so the direction is changed. Otherwise, your answer would be correct. The direction would be opposite. So if you consider the directions of motion in the example like they have given to us, okay, VA, VB, and VB, VA, VB, finally, initially. We use the same directions of motions right now as the example. So if we try to input the values now, so mass of A is 2 and velocity of A is in the positive direction, which is 3. This is the momentum of A. Plus mass of B, which is 0.5, and the velocity direction together, the velocity is -5 because it is on the left side. And this is equal to, again, mass of A is the same, mass doesn't change, and times the final velocity after collision of A, we are considering it to in the negative direction. Okay, -2. Okay, they ask you for the 0.5 times the velocity of b, which is right now we have considered in the positive direction because it is on the right side. Okay, so now we find this vb. So what do? We simply solve this. So 6 minus 2.5 is equals to minus 4 plus 0.5 vb. So this becomes 3.5 plus 4 is equals to 0.5 vb. So this will become 7.5 divided by 0.5 is vb. So this means that the velocity of b would be 15 meters per second to the right side. We've got a positive answer. So this means the sign convention is correct. We have, so b would be moving after the collision 15 meters to the right side. समझ आया? This is how you form the equation. Okay, any
Yes.
questions?
No. No, sir. Clear.
Copy कर लो ये formula, copy कर लो on how we form the equation. This is not a very difficult topic, but initially this might seem a little bit tricky, but overall you'll see the questions are very repetitive. Okay, 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 okay. Okay, let's do a practice work question over here. Okay, so two ball bearings are moving towards one another. Okay, two ball bearings are moving towards one another. The first ball bearing has a mass of 20 gram and moving with 3. The second is 25 grams moving at 1. So initially, two ball bearing, this is 20 grams. Let's suppose this is 25 grams. They are moving towards one another. So one would have this 20 gram would have velocity of initial velocity u of 3, and this one would have initial velocity u of 1. Okay, this is the thing which we have given us right now. After collision, the first ball bearing is stationary. So the first ball was the 20 gram one. Okay, so after collision, this becomes stationary. So this becomes velocity, final velocity becomes 0. What is the speed of the second ball bearing after the collision? So what is the speed of the second ball bearing? We don't know final speed of the second one. So we would do again conserve the momentum over here in this case as well. So initially momentum would be 20 gram, which is 0.02 times 3. Okay, in the positive direction is 3 plus 0.025 times minus 1. Okay, because on the velocity to the left side is equals to 20 gram 1 is 0. Okay, final velocity. So momentum of the 20 gram after collision would be 0 plus 0.025 times velocity of b, final velocity of b. Sorry, final velocity of the second ball. So what would you get? Use the calculator. So 0.02 times 3. Sorry, 0.02 times 3 plus 0.025 times minus 1. And this thing divided by 0.025. So velocity is coming out positive 1.4 meter per second. So it is going to the right side because the velocity value is coming out positive. So the 25 gram ball bearing is going to the right side. Okay, do you get it?
Yes, sir. It's clear.
Good. Let's do another one. It's done. There's nothing more in this topic. Conservation of momentum. That's it. This topic is very unique. It's a little bit difficult when you go into M2, but they have removed that M2. So this is it for this topic. Let's do one more. I'll do one more with you, and then you people will try one. Okay. So there is a ball of mass. Question number 2. I'm doing question number 2. A ball of mass 0.04 kg is moving Speed, a ball of mass 0.04 kg. Speed is 3. When it hits a stationary ball, so there is a stationary ball of mass 0.06 kg. After the impact, the first ball is stationary now. So okay, so after the impact, this 0.04 velocity final becomes 0. Find the speed of the second ball. The second ball would definitely, right now, it's very, what do we say, easy to predict. It would go to the right side. But let's see. So initial momentum would be 0.04, which is the left side ball times the velocity of the left side, plus velocity of the second ball is 0, so momentum would be 0. Final momentum of the first ball is now 0 because velocity of the first ball is 0, plus 0.06 times final velocity of the ball B, the second ball. So 0.12 divided by 0.06, which would be 2 meter per second to the right side. So this ball is going to move now with 2 meter per second to the right side. Positive. ठीक है. Okay, I'll do one more and then you people will try one. A box of mass 25 kg slides down a slope. So let's make a slope. So there's a box of mass 25 kg. Slides down a slope until it has reached a speed of 5. Okay, so initially it is 5. When it then travels at 5 horizontally across a smooth floor. Okay, so now it is going to move horizontally with the same 5. Okay, until it bumps into a stationary crate. Okay, so there is a stationary another crate with this which is stationary. Immediately after the where is it? Immediately after the impact, the box reverses its direction and travels at, so after the contact, let's suppose this is the first after contact. So this one would reverse the direction. It is now moving on the other side, reverses its direction and travels at 0.5. The crate starts to travel at 2.575. Wait a minute. You had a box of mass and then so okay, so this is the box and this is the crate. What's the difference? So the box had mass 25. Crate mass we didn't know. Okay, we don't know the mass of crate. After the impact, box reverses the direction and the crate starts to travel at 2.75. Okay, so crate is starting to move to the left side definitely with velocity of 2.75. So they are asking you to find the mass of the crate. Okay. So initial momentum of the box is 25 kg times velocity is 5 plus mass of crate times velocity of crate. Crate was what do you say? Stationary, so 0 is equals to the box of what was it? Mass of the box was 25 and now it has reversed direction, so negative 0.5 plus mass of crate times the velocity. Right now we have not considered the negative. Okay, so this should be negative because initially the box is moving to the left side. So crate is also going to move to the left side after collision, and this would be positive. Okay, so 2.75, and now we want to find the value of the crate mass. So use calculator now. So 25 times negative 5, and this would be minus 25 times 0.5, and this answer divided by negative 2.75. So 50 kg. This is the answer for the mass of the crate. समझ आया?
Yes.
Okay, Murtaza.
Yeah.
Murtaza ने बोला था अच्छा. Amaz, good, all good.
Yes, sir. It's clear.
Okay, now look, this is a very big topic. Oh, big question. Let's do a smaller one first. Two ball bearing. We did the ball bearing one. Okay, this one. Okay. There's one more thing. Coalesce. There's look. There's one more thing over here. Coalesce. They use this word as well. Coalesce is when they join together after the impact. For example, that there is a car traveling, okay, and there's a truck coming in from behind with a very large, very big speed. Okay, what do you say? A speed of very large magnitude. So what would you assume? That the truck would be colliding with the car and taking the car as well with itself. So now they both have combined, and the mass is now combined together. Okay, so they have coalesced together. I don't know how to properly pronounce this word, but I have been using this coalesce. I say like this. So this is the word coalesce. When the masses combine, they now move together. They have joined together. Do you get the example? For example, there's a very mass, a very heavy truck, and it collides with a car from behind, and the velocity was so large then that it is now taking the car also with itself. So now they have a combined velocity. So the both of them has combined. The masses have coalesced together. Okay, so this is another word they use. So first of all, not the coalesced one. Forget about the coalesced one. Try to do the simple one first. Okay, try this one. This is, I think, a little bit of kinematics as well. Okay, read the question properly. Try this. Let's see. The second part is, look, they have combined that the balls coalesce and the combined object falls to the ground. So you will find the combined velocity of the balls as well. Okay, the velocities would add up, and then the rest of it, once you get the velocity, then the rest of it is kinematics.
Yes, sir, I got
Well,
for A bit.
you found
I found
just before
velocity.
you found the downward momentum of each ball just before the meet.
No, I'm almost there. I found the velocity. I just remember.
Hmm. How did you get the velocity when they meet?
I first found the time and then use v is equals to v plus 8.
How did you get the time?
I use SE because both distance, if we add both of distance, right? Distance of y and x, it is total is 30, I meant. The
Why?
total distance 30.
Initially,
Because, yeah,
initially. Mm-hmm.
so I found Sx, which was 5t square, and the distance of y, which was 20t minus 5t square. And then I added Sx plus S of y, the distance of y, which is equal to 30.
But this won't be always 30. As time would change, the distance between them would change, isn't it?
No, sir, but the total distance they travel would be 30, right? Both of them together.
Hmm. सही है. Ball X would come down some and ball Y would come up some distance, and then yes, you can do that like that. Hmm. Nice. What is the time that you're getting?
1.5. 3 by 2.
Time is 1.5 seconds. Good. Good. ये मोर्तज़ा था कौन था? अमाज था.
G, what's the
अमाज क्या सीन है?
I could not solve it.
Look, Mortaza told us, gave us a very good idea. They told that he told us that initially ball was at a height of 30, right? Let's suppose this is the ground. This is the ground. So ball X is over here, ball Y is over here. Distance between them is 30 meters. Okay, ball X is coming down. Initially from rest, acceleration would be G, right, which is pulling it down. And time, we don't know when they both would they both would, what do we say, and what do we say, meet. We don't know the time when they meet together. For Y, initial velocity is upwards, which is 20, and acceleration would be -10 for Y, because this would be stopping. The G would try to stop it, right? Because it is upwards. The G is downwards. Okay. Or if you keep this thing positive, if you're keeping the downside positive, then your U will be negative. Okay. If your this should be negative, then if you use the same sign combination, right, for both of them. So downward is G, which is positive, so upwards we take it as negative, so -20. And then what do we have more? Find the downward will. Okay, so when they would meet, definitely this is coming down, this is going up. At a certain point they both would meet. So they would meet. This means that distance that Y has traveled and the distance that X has traveled, they both combined would be equal to 30 meters, right? Because this difference between the distances would become zero when they combine, when they would collide, है ना? So this means that the displacement of X, or the distance of X plus the distance of Y, would both be combined to get a total of 30 meters. So that जितना X ने मूव किया और जितना Y ने मूव किया है, अगर दोनों को मिला के 30 मीटर दोनों ने मूव किया है, so now the distance has become zero between them, because initially they had a difference of 30 meters. सही है? So now S is equal to UT plus half VT square, you can apply over here. So, or the other way around, for X, UT plus half VT square, UT is 0, half A T square, plus Y would be UT -20T plus half A T square is equals to 30. So this would become 10T square minus 20T minus 30 is equals to 0. And when you would solve this, your T would come out to be 3/2. I think one of the solution was 3/2. So they collide when the time is 3/2. 10 minus 20 and minus 30. So -1 and 3. Wait a minute. 10T square minus 20T, and then plus 30, so minus 30. 10 minus 20 minus 30. अमाज मुर्तजा चेक करो मैंने क्या साइन में गलत क्या
Wait, so how do we get 10T square?
S is equal to UT plus half T.
No, but won't they cancel?
Why would
Oh,
they cancel?
sign. Okay, okay. I did because for me it was minus. Sure. I took the opposite sign.
We are talking about displacement, right? The distance. Distance. If we talk about the distance, then okay. Wait a minute.
इसमें हम लोग G माइनस नहीं लेंगे उसके Y के लिए.
Yes.
Y के लिए क्या? G -10.
G.
Yeah.
Initially मैंने वही रख रहा था, फिर मैंने चेंज किया. I don't know why. एक मिनट देखने दो. If we take this as negative, so ये वाला भी तो नेगेटिव लेना चाहिए फिर. For X के लिए.
कह रहा हूँ कि इसके लिए हम जैसे अगर नेगेटिव लें.
इसको नेगेटिव लिया, इसको भी नेगेटिव लिया, इसको पॉजिटिव लिया. So this would become negative, and this is positive, and this is negative.
No, sir. Only one G will be positive and one will be negative.
ऐसा
एक
क्यों?
नीचे जा रहा है और एक ऊपर जा रहा है.
सर एक इन फेवर जा रहा है ना, एक और दूसरा जो ऑपोजिट जा रहा है. ये वाले के लिए
सही. If I want to find the distance this X has traveled, so ठीक है, it has traveled distance की बात कर रहे हैं. Okay, so we are not right now focusing on the direction of the motion. So distance would be, if you take it positive, so s of x would be u t plus half a t square, and the distance for y 20 t, and this acceleration is trying to stop it, so minus 10 t square, and this would be the sum should be okay, is equals to 30. Okay, सही है, सही है, सही है. Good one. So now you would get the time as 3 upon 2. And now this time 3 upon 2, you can find the final velocities. V is equals to u plus at for both of them. So V of x is initial velocity of x is 0, acceleration is -10, and time is 3 upon 2. So this comes out as -15 at the point when it is just about to collide. So yeah, and then V of y, initial velocity is 20 plus it is coming down. So x is coming down with a velocity of 15. Okay, forget about the signs. This is -10 and 3 upon 2. So V of y is, we're getting 5 positive. So this is coming, still going up with a velocity of 5. 3 upon 2 time. Okay. सही है, सही है, सही है, ठीक है. And now they are combined. So now we would use the momentum formula. Momentum, initial momentum and final momentum. So initial momentum of x, the mass of x is 0.03. So 0.03 times 15. We are taking downwards. We should take downwards as negative. Plus y is y comma 0.01. Upwards 5 positive is equals to, they are now combining. Okay, so when they combine, so total mass would become 0.04 times the final velocity of the x and y combined. So this would give you the, let's see, 0.03 times -15, -0.15 plus 0.05. 0.03 multiplied by, sorry, क्या कबाड़ी कर रहा हूँ मैं, -15 times, sorry, plus 0.01 times 5. Okay, this divided by 0.04. So V x y is -10. So now they are both moving down because we took the negative sign downward, right? So now they are both moving down with a velocity of -10. And how much distance have they covered? They would fall that distance, right? Find the distance that y has covered. Okay, so sy is 20 times 1.5 plus 0.5 times -10 times 1.5 squared. So 18.5. So now they have combined at a height, they have touched each other at a height of 18.75, and now they would both move down with this, with the velocity of -10 initially, and show that both combined objects reach the ground 2.68. So now the displacement is -1.18.75. Initial velocity is also downwards, -10t plus half a is -10, and time. So you are getting -5t squared, -10t, and plus 18.75. S is equals to ut plus half at. So -5, -10, 18.75. कुछ गलत किया, अभी भी गलत किया, क्या गलत कर रहा हूँ यार. After x has started to fall. Okay, after x has started to fall. So we have found the time. This is the time, 1.179, 1.18 seconds. This is the time it took for them to fall after this, after the collision. So what is the time from the instant that x has started to fall. So how much time this part took? How much time this part took? So v is equals to u plus at. We can use what should we use? Yes, we can use v is equals to u plus at. So v final velocity is 15, initial is 0, acceleration is 10. Oh, we already have this time. 1.5, sorry. This time before they just collide, this is 1.5 seconds. So total time that they took was 1.5 seconds plus this 1.18. 2.68. सही है, आ गया, गुड, समझ आया?
Yes, sir.
So look at the importance of the directions. So important. So if you don't take the directions properly, look, I can also make mistakes. These are very common mistakes. I have made them a lot in my time. I can still recall that. That's why I take some time to solve this. Direction सही होंगी तभी 5 से सही आएंगे, वरना फिर look, you get the wrong ones. Okay, I think that's it for today's class. We'll start off with more past paper questions tomorrow. Okay.